This is selective precipitation. Physically, let's understand what's going on here in the beaker. We have this beaker. It contains silver plus ions and lead 2 plus ions and mercury 1 ions. And all these have the same concentration, 0.0015 moles per liter. And what we're doing is adding sodium chloride. So we know that sodium chloride is going to release sodium and chloride ions in solution. So effectively, we're increasing the chloride ion concentration. And as a chloride ion concentration, first one, then the second, then the third of these ions will precipitate out as a chloride, because these are all insoluble chlorides. Now, in a previous problem, and here's the name of the video, in a previous problem we determined what ion concentration the chloride needs to be in order for each of these systems to be at equilibrium. Alright, now this question, we want to precipitate out all of the ions except for lead. Lead is much more soluble than silver chloride or mercury 1 chloride. Oh, and a reminder, we have all the KSPs in that other video. Alright, so let's envision what's happening here. We have the chloride ion increasing. The first compound to precipitate, Hg2Cl2, mercury chloride, mercury 1 chloride, will begin to precipitate when the chloride ion concentration gets above this value. Because at this concentration, the lead chloride system is going to be at equilibrium. We need to get an ion potential or ion product that's greater than this in order for the precipitation to occur. So we increase the chloride ion concentration above this value, and Hg2 2 plus ions are removed from solution as the precipitation occurs, and we form mercury 1 chloride. So we continue adding chloride ions, it removes the Hg2 2 plus ions. We continue adding sodium chloride solid, and the next chloride to precipitate is a silver chloride, and that occurs when we have a chloride ion concentration greater than this value. Okay, but we want to precipitate out the silver chloride as well as the mercury 1 chloride, so we can continue adding our sodium chloride. Okay, so Ag plus ion concentration is decreasing, and the mercury 2 plus ion is decreasing. Both of these are decreasing because both compounds are precipitating at this point. Okay, you need to stop adding Cl minus, or and thus sodium chloride, when the chloride ion concentration is equal to 0.11. Because above this concentration, our PbCl2 is beginning to precipitate, and we don't want that. Alright, so we go on to the second part of this question, and that is, what is the concentration of the mercury 1 ions in the solution when PbCl2 is at equilibrium and just before PbCl2 is beginning to precipitate. So what we have here in the beaker, and let me remind you, is we have the solution, and down here at the bottom is silver chloride solid, and we're also going to have mercury 2 chloride solid. And what we have in here is primarily Pb2 plus ions. They're still in solution. Virtually all the silver chloride and the mercury 1 chloride ions have been precipitated as a solid. But I want to prove that to you, i.e. we're going to calculate what concentration of mercury 2 ions are still present in this solution. It's going to be very low, but it'll be there. What concentration still exists in solution when lead 2 plus is in equilibrium with its chloride. Okay, so we have PbCl2 solid in equilibrium with Pb2 plus and 2 chloride ions here, okay, when our Cl minus ion concentration is equal to 0.11 molar. Okay, so we want to calculate Hg2 2 plus ion concentration at this point. So we're looking at the following equilibrium. Okay, in this instance, we know what KSP is. We know what the chloride ion concentration is. We're trying to calculate what the mercury 1 ion concentration is. So KSP is the mercury 1 ion concentration times the chloride ion concentration squared. So Hg2 2 plus ion concentration is going to be equal to the square root of Ks. No, it's not the square root. It's just KSP. KSP divided by Cl minus squared. And this equals our KSP value of HgCl2 is 1.4 times 10 to the minus 18 divided by 0.11 squared. And that gives us Hg2 2 plus ion concentration is equal to 1.16 times 10 to the minus 16 molar with 2 sig figs. Okay, now if there is Hg2 plus ion concentration in this solution, however its concentration is 0. Pretty gosh darn small.